Okay, here's the view and example that they have. And so if you can get yourself down to the point of the z-value, or the z-value, this is how you would do it. So remember that before it was norm.dist, there it is, that one right there. So it was that one. The x value, the mean, standard deviation, this is where things are going to change just slightly. Because it's a z-score, that basically means that you change the whole thing from all these x values to z-scores, which hopefully you understand. It standardizes it. Kind of like how instead of it being like test scores, it's now GPAs, or you're standardizing it. So basically, when you standardize it and using the z-scores, the mean is 0. The standard deviation is 1. So here where it says x and you're using a z-score, you just type in your z. The mean is going to be 0. When you're dealing with z-scores, the mean will always be 0. When you're dealing with z-scores, the standard deviation will always be 1. Okay, and we're going to accumulate this one. Now, this is always going to be the area to the left, okay? So to make it the area to the right, which is the greater than sign, just simply say 1 minus that, okay? And there you have the z-score. Let me get you down to another one, okay? So it's company B. Again, if you can get down to the point where you've got your z-score, okay, you're looking at your z-score. You're trying to figure out what the probability is of z being bigger than that number. So it's 1 minus norm.dist. Okay, the x value is going to be your z, 1.09. The mean, again, because we're using the z-scores, your mean will always be 0. When you're using the z-scores, not the x's, okay, don't get that confused. If you're going back and using your x values, wherever they are, your x values, it would be different. But because we have it standardized to a z-score, your mean is 0. Your standard deviation is 1. Okay, and then we're going to say true for that, cumulative. Okay, and there you have your probability.